Hello everyone. In this tutorial, I'm going to demonstrate the use of reactive programming in Swift. Of course, for the building of OS X or Mac application. There are several popular reactive programming libraries available. You may have heard of Reactive Coca, Reactive or Interstellar. Out of these, I'm going to show you this yet another library called RxSwift, which is maintained and originally built by the Reactive X community. They have a port to Swift, and we are going to apply this into our Coca application. First of all, in order to add RxSwift, I can install it using one of the several ways described on the repo. It can be through CocaPods or Carthage, these kinds of dependency management system, or adding it manually. In this case, I'm going to show you through using Carthage. And the first thing to do is to add this line to cat file. Due to time constraint, I have done that already. And this is what my cat file look like. Just one line of the repo. And then after that, I run Carthage update, which will download the repository and then build into different frameworks. As I didn't specify the platform to build, it builds all the frameworks, while we only need the OS X version. Next thing, I'm going to add the framework to our project. So first head back to the project and find the project settings here. And then this is the folder. The cat file folder is generated after running Carthage update. What we need to do is to find the build part for the build framework, navigate to Mac, and I'm going to use RxSwift in our project, but we will be using RxCode as well, where it provides a lot of extensions to the AppKit elements so that we can observe on the changes for those app components or bind the stream to those components so that the UI elements of AppKit can be used for RxSwift. So highlight these two frameworks where we need, and then drag them into the project under the embedded binaries. As you can see, it adds to the link framework as well. Right now, go to the build phases and add copy file phase. Choose product directory here, and then head back to the file where we are going to drag the DSYM to Xcode like this. The import is basically done, and we can try to import the framework to our source code and see whether there's any problem. Run the application right now. As the application starts successfully, It means that in import of the frameworks, the basic installation part is done. I'm going to first show you about the basic use of RxSwift. In the repo, the documentation about RxSwift, you can find the usage on how to use RxSwift. The fundamental idea for RxSwift is called observable. You can also call it sequence. And the whole concept or workflow here is based on more like a pub-sub mechanism. You can publish a stream of events and then you can subscribe to it. Say I can publish with a set of numbers, and by subscribing to this sequence, I can do whatever I like. Or the publish part comes from some UI element change, and then we can subscribe it to perform the layout update accordingly. So in terms of RxSwift, we can start by defining a sequence here. Say I just call it sequence, where it provides a sequence of numbers. We can create this sequence using the observable class here, and there is a function called of. So it's literally phased as observable of some elements. We can pass different types of values here. For simplicity, I'm just passing it a sequence of numbers. Say 1, 2, 3. Each of the value here represent an event. So it's basically passing in 1 and then 2 and then 3 in this particular order. We have basically done the publish part, and then I'm going to subscribe to this sequence. The way to do that is to make use of this sequence. Then yes, we can use a dot subscribe and take this as the subscription to the sequence. In the subscribe method, I can provide a block which will become the action after the event is happened. Say I can simply print the value out of it. $0 is like the first parameter passing into this block. There may be a warning sign here, as subscribe method itself should be able to return a disposable object, whatever it is for now. But we are not using this return result. We can simply by doing the underscore equals to tell the compiler that we will not be using the return result. It has some optimization benefit to the compiler. If I run the application right now, we can check the console for printing out the result. As we are publishing 3 events, 1, 2, and 3, the subscription will print those accordingly. The next here is defined by RxSwift being going to the next event. Of course, we can unmap it back to the integer but it shows you it is how the sequence works. Say if I want to process the sequence of numbers a little bit before printing out, I can change the actions here, say using the map operator. It passes in the number so that we can define what to change based on each of the number passing in. Say I just want to multiply it by 2. The map operator here knows it is number because by defining the observable of number sequence, the sequence here becomes using the type of integer. Thus, by the generic nature, it will know every sequence passing in is a number. Then we can use the map operator, which works similarly to the map function in Swift, to handle each of the numbers in the sequence. And then eventually, we just subscribe to the change and then print out the result. We should expect in the next time of run, the result will be showing next 2, 4, 6, and let's check. As you can see, this works as expected. For the completed message here, it means the sequence we have created is just finished. There are cases that the sequence is never finished. Say we are gathering some live data from the internet, but in this case, as we predefine the sequence manually, it knows to complete after every number inside the sequence is processed. Just now we have looked at the simple example of using RxSwift. Let's try to use this with the AppKit components. In order to achieve that, we need to import the other framework here, which is the RxCode. RxCode is part of the RxSwift project, and it provides several extensions to the app components. Say if we have the NS test field, it provides the method to observe the change to the test field, and we could also bind the handled value back to another test field. In order to show you how to use this, let's head to the main.storyboard, and then we are going to add the test field here, and also add a label here. Our intention is that when I make changes to the test field, the label will be updated accordingly. And say I'm calling this as test field, and the label here as label. So the next thing is that I'm going to observe the change of the test field. Say I'm calling this as test field sequence, which equals to the test field dot RxText. This is the method provided by RxCode. And then I will say observe it on the main scheduler. Literally, main scheduler means I'm observing it on the main thread. And then I'm going to bind to, which means it is a way to subscribe to the event change, but it will bind the result to the target element, and in this case to the label. And I will use RxText here as the target attribute I'm binding to. This will eventually show as the string value of the label. I'm going to add an instance here called dispose bad, where we can, after bind to, add this disposable to the dispose bad I just create. This means if the sequence is finished, dispose bad will handle the disposal for you. Let's try to run the application right now. Now if I make changes to the test field, the label will be changed accordingly. So unlike the traditional way, I don't need to grab the value from an IP outlet and then maybe define an IP action where it is triggered by the change, and maybe set to another label using that IP outlet, etc. The code looks a lot more cleaner with the reactive programming paradigm. A general practice here would even separate the publishing part, which is the reactive source, and the target, which is the subscription part. We can do it like this. So if I have more than one reactive source, I can define them and group them together, and then process it in the middle and bind to the final value later on. Let's just to run it again and see it works as before. This is a quick demo about using RxSwift. I hope you enjoy, and let's take a look on this more in the later sessions.